All right, so we are in Unit 3. We're going to do Lesson 5. This is actually Part A of Lesson 5. The topic is called partial fraction decomposition. Again, big fractions, we break them down into smaller pieces. So, let's go back to something we did in the prerequisite unit. How would I add these two fractions together? What would I do? All right, so you're in your head already, you've determined that the LCD is going to be the combination of both denominators. So I'm going to take the first one and I'm going to multiply it by x plus 3, and the bottom also by x plus 3. The second part of the fraction gets multiplied by x minus 2, but again, we have quantities initially, even though there weren't parentheses there. Up top, we distribute, so we end up with x plus 3 plus 3x minus 6, and in the bottom we end up with our LCD, which is x minus 2x plus 3. Yes? What would be our next step? Combine like terms in the numerator. When we do that, we end up with this final answer. What our goal is with fraction decomposition is to take this final answer and do enough work to end up with what we started with at the beginning. We are going to figure out which two algebraic fractions, add or subtract, it could be, in order to give us this combination. What? Doesn't that sound like fun? Yes, it's like the ultimate math magic. But there's actually a process to it. All right, so here we go. Let's just jump right in. All right, do you have these steps listed at the top?
Yes.
All right. They are there for your reference. I am verbally going to go through them. You don't have to copy them. We're not going to waste the time on that. So let's start with our linear factors. Okay? Linear factors means that we need to take the denominators and determine what they break down into. So what can I factor my denominator here in blue? I can take out an x first. That gives me x squared plus 2x minus 3. Then what? Does it factor further? There you go. Okay, so step 1, take your denominator and factor it, break it down as much as you possibly can. If you miss going from the trinomial into these smaller factors, your answer isn't going to be broken down as far as it should be. Okay, now, when we talk about linear factors, what we mean is that linear factors, examples of this would be x minus 1, x plus 3. They're factors where the highest power of x is 1, hence linear. Okay, so this is a linear factor, this is a linear factor, and this is a linear factor. Okay. Now, if I take my original problem, 4x squared 13x minus 9. I rewrite it. I'm going to set it equal to the sum, for now, of 3 fractions. One fraction, denominator x. One fraction, denominator x plus 3. One fraction, denominator x minus 1. All right, so let's come over here. Ax squared plus bx plus c. Ax squared is the quadratic term. Bx is the linear term. What's c? Constant. Okay. Do you agree that I've written this trinomial in descending power order? Yes? So technically, linear is 1 degree less than quadratic. Constant is 1 degree less than linear. We're good with that? Okay, this is important for what we're doing and what we're going to do tomorrow and expand upon. If my linear factors, I'll put plus signs in. We can change those signs later. For now, we'll leave them as positives. If my factors of my denominator end up being all linear, my numerator always is 1 degree less. So notice, if I have linear factors in the denominator, that means I'm going to talk about constants. So I want to talk about the constant A, B, and C. Now I want to be clear about something. By A, B, and C, I am not relating to these A, B, and C's. What I'm saying is, I want to talk about a constant, and I want to call it the constant A, could be the number 7. The constant B could be -3, and C could be a different value. It could be 5. I'm using letters to represent them. A and C could both end up being 5, but I don't know that. So don't confuse the coefficients of this with what I'm writing here. I'm trying to liken it to something you already know to understand the vocabulary of linear factors. Don't confuse those concepts. So to review, you take your original function, you factor the denominator, you write out a statement that you have each one of the factors as separate fractions. 1 degree less, you're going to then indicate in the numerator. This is the equation we're going to end up solving. How many unknowns does it have? Technically it has 4, right? We're going to be solving for A, B, and C. If we find A, B, and C, then x can be any value because it'll always be true. Okay, step number 1. Step number 1. We are going to, from this point forward, multiply the entire equation by the LCD that we determined. So I'm going to multiply this by x plus 3, x minus 1. When I multiply the first fraction, everything cancels, leaves me with 4x squared plus 13x minus 9. When I move to the next factor, the x's are going to cancel. It leaves me with a times x plus 3, x minus 1. Moving to the next fraction, the x plus 3's cancel, leaves me with an x and an x minus 1. C is going to be x and x plus 3. Factor. Set up your major equation. 1 degree less, multiply by the LCD, which puts us here. Okay, next step, going to purple. What are the zeros? What makes each one of these red denominator values 0? What are those zeros? 0 is 1, -3, and 1. Okay, so I'm going to make a list of the zeros that turn the denominator into 0. Now, this is a little bit tricky because remember in the last section we said zeros never come from the denominator. Zeros are x-intercepts. They're only defined in the numerator. The step or process of this is simply saying what are the zeros of the denominator not related to graphing. Just what's going to make the denominator 0. Okay? So now what I do is I plug these in for x. So I go back to my red line right here and I plug them in. So I get 0 plus 0 minus 9 is equal to a times 3 times -1 plus 0 plus 0. This is the part where I always get the, wait, why are the zeros? Why are they zeros? Why did this get replaced with a plain old 0? If I plug a 0 in for x, 0 times anything is always going to be 0. This is why this strategy works, because notice we've now eliminated 2 variables, b and c. If I solve the equation that's left, -9 is equal to -3a. What's a equal to? A is 3. Maybe be guided? Check with his guidance counselor. All right, now, you might have missed this as I walked by like Vanna White. A is 3. Notice I went up and replaced A with 3. Okay, now we do the same thing with negative 3. This is what I mean by the tediousness of it, that what we're doing isn't really hard mathematically, but it's tedious. So 4 times 9 is 36 minus 39 minus 9 is equal to, now notice when I plug negative 3 into here, doesn't it give me a 0 in the next A grouping? So I've got this grouping here, right? And then I'll make this one the B thing. The straight line grouping, when I plug in a negative 3, generates a 0. So this ends up going to 0 plus, well now when I plug in negative 3 here, I've got B times negative 3 times negative 4 plus, what happens when I plug negative 3 into the V line? The V's. Plug a negative 3 in here, I get 0. So this one also goes to 0. Woo, good times. So negative 12 is equal to 12B. What's B? B is negative 1. Okay, so now take a look when I come back up here, Vanna White style. I'll walk across like she does. Over to here. I don't put a negative 1 up top. I change this sign to a negative, and I make B a 1. Yes.
For A, when you put like in negative 3, how'd you get like completely 0? Because I know x plus 3, put the negative 3 into 0, but then x minus 1.
Right, but it's going to be A times 0 times something. Anything times 0 is 0. Yep, it's the multiplication feature of it. Okay? All right, everybody's good with that? Plugging that in here? All right, next up, plugging in a 1. So I plug in a 1, I'm going to get 4 plus 13 minus 9 is equal to 0 plus 0 plus C times 1 times 4. What's C equal to? C is equal to 2. So what I have right here is my final answer that I was looking for. Welcome to fraction decomposition. Sure. 4 plus 13 minus 9 is equal to 0 plus 0 plus C times 1 times 4. You get 8 is equal to 4C. C is equal to 2. Where all I'm doing is where that purple arrow is, I'm plugging in 1 for x. 4 times 1 is 4. 13 times 1 is 13, and going right across. All right, so my intention here today was to show you my work, quell the fear up, get you to pay attention, and now we should start to be coming down like, oh, well, maybe this isn't so bad, okay? But now you're waiting because now you're like, oh, maybe she's going to take off again. No, I'm not going to take off again, okay? If you look at the next example underneath, I want you to try this one on your own, and we're going to do this one verbally where I ask you to do the step, and then I'll put the work on the board for you. Yes, there are some of you that are just going to sit and wait to watch me do it, but I want you to try to understand the process where you don't have to read. So we're going to do this kind of more of an auditory skill. So if I look at number 2, step number 1, factor the denominator. Factor the denominator. Did you get something like this? Yes. Okay. Step number 2, put an equal sign after your fraction and set up 2 linear fractions on the right. So you should have two denominators. One of them is x plus 3. One of them is x plus 1. Put an equal sign right next to here. So what I'm saying is you can just go right to here. And I want you to set up two fractions. One with the denominator of x plus 3, one with the denominator of x plus 1. What goes in the numerator is 1 degree less. So these are both linear. So I should see a capital A and I should see a capital B. So if you're following mine, x plus 3. I'm trying to have it look just like your notes. That U3 is kind of in the way. Next step, multiply the entire fraction by what would be the LCD. So I want you to do that work. Multiply. You should get one line of work right here. Go ahead and multiply through. Write it out. So you're going to start with x minus 2. Equal to a times something plus b times something. A has to be what's missing, b has to be what's missing. All right, next up, determine the zeros of the denominator. So go to what you multiplied out here. What are your two zeros? Write them down. Carefully plug them into the red line of work that you had up above. Solve for A. Solve for B. Did you get fractions? Okay, for my one value, what do I have here for my A? I have 5 halves. Okay, now let's talk about something here because this is important. 5 halves. For B, I have negative 3 halves. All right, now, if you have a different order for your A's and B's up here, you're going to get the same answers. You just won't have A equals and B. You'll have these switched. So you'll have A is this, B is this. That's actually how I did my notes. Okay, but you should get the same two values. And what's important here is the following. When I go back up here, okay, you're going to be inclined to, for instance, A, to say, oh, okay, this is 5 halves. You can't write a fraction inside of a fraction. So let's take what this is one time to understand the process. 5 halves divided by x plus 3. From prerequisite unit, what's the denominator of the bottom? What's x plus 3 over? 1. What's the rule with fraction divided by fraction? Multiply by the reciprocal. So technically, this is 5 over 2x plus 3. Up here, the 5 should be in the top, and the 2 goes to the bottom. So if you had to guess, what do you think B is going to look like? Negative here, 3 up top, 2 in the bottom. Background theory, application to the problem. What do you think? Like it? Don't like it? Okay? Tedious, not hard math, mathematically. Okay, so up here I'm going to write ax squared plus bx plus c. We're going to do some math. It's going to be amazing. Are you ready? Flip the page. Erase. Erase. Okay, so let's talk about the denominator of 9. Just the background knowledge here. If I start with the denominator of 9, do you know if I was adding 1/3 or 1/9? Wouldn't both of these add up to a denominator of 9? They could, right? I could be adding ninths together, or I could be adding thirds, which then you could translate into ninths. Yes? The reason I want to show you this is, what if instead of a 9, what if I wrote it as 3 squared? Do you notice how I could have 3 to the first, or I could have 3 squared being added together in order to get this, like in a theory, if I expand on that definition? Does everybody see that? Like 2 and 4 would be the same thing? 1/2 plus 1/4 could give you fourths, 3/4. Yes? Okay. Today's second topic is repeated linear factors. This is what we mean by that. Repeated linear factors are these. Repeated linear factors. They are a factor that has an exponent of 2. There's a special case involved in this. Everything we've done to date stays the same. So do you notice how this is already factored? Yes? That saves you one step of work. So over here I have that x squared plus 10x. I think you have this written as your problem in your notes already. Yes? Okay. Here's the repeated linear factor. Okay. One denominator is x. Plus, I'm going to have x minus 3 to the first, and I'm going to have x minus 3 to the second. I need to include both of those. I don't write this as x minus 3, and make all of them linear. I write it like this. This is a special case. You've got to be able to identify it and know that those are the steps you have to take. And it goes back to what we just talked about with the denominator of 9, 1/3 and 1/9. We have to check both of them. Now, the tricky part here is that this is still A, this is still B. Okay, I'm going to put a star here. This is still going to be C, even though if we multiplied it out, we would get a quadratic. We would get ax squared. It's still going to be a constant value because this is a repeated linear. Repeated linear goes back to just C. Okay. Now what do we do from here? Everything's the same. What do I multiply the whole equation by? What do I multiply the whole equation by? X times x minus 3 squared. Do I have that here? Yes. X squared plus 10x minus 36 equals. Now be careful. This is where some of you who aren't strong in LCD, you need to really kind of pull yourself up by your bootstraps and pay attention. I have an x. I have an x. What don't I have? What don't I have in this first fraction? X minus 3 squared. So I'm going to take A times x minus 3 squared. Plus, and what is B missing? X and x minus 3. What about C? X. me a favor. Leave a space. We're going to come back to this one, and you're going to know when to leave a space once I get through the problem why we're doing that. Leave a space for a line of work there. All right, so my next step is to go to zeros. What are my zeros? 0 and 3. This is how I know I had to leave a space. How many fractions do I have? How many? 3. I have 3 unknowns, A, B, and C. How many zeros do I have? 2. Well, if I plug in, I'm only ever going to get 2 variables, right? One of them is not going to be solved for, and I don't have any more zeros to plug in to get the other ones. That's how you know you have to leave a space. Yes, sir? But you're going to get the same answer. It's going to reduce to the same letter if you write the second one. Agreed? Right? Like you're going to do all the same work again, and it's going to generate the same solution. You're never finding the other variable. So that's why this space becomes important. Let's plug in 0 real quickly. 0 is awesome. It's one of my favorite ones to plug in because I get 0 plus 0 minus 36 is equal to a times negative 3 squared plus 0 plus 0. What's a? I'll finish this very quickly. A, if you check your notes, you should get negative 4. Negative 4. Okay? So A is negative 4. Perfect. Negative 4. Now I do B. Okay, so I plug in 3 rather. 3 here. I'm going to get 9 plus 30 minus 36 is equal to 0 plus 0 plus CX. I'm going to tell you if you do this work. You want to stand? Indivisible. Justice for all. C is going to give you 1.
Good morning, Roberts. A couple of quick announcements. Indoor track and field sign-ups and informational meeting will be held on Tuesday, October 24th at 2:45 in the senior cab.
As soon as announcements are done, I'm going to just do this last line of work. I apologize. I never go into homeroom, but we need to just for today.
After school at age 3:05 for anyone planning on trying out for the team. All necessary paperwork will be
Don't put it away yet.
and important dates will be discussed. If you have any questions or can't attend, please speak to Coach Childs. Last day, juniors and seniors, to go to your grade level office if you do not wish to have your name appear on a list that will be sent out to the recruiting officers for the armed forces. Congratulations to our girls tennis team who won their semifinal District 11 meet yesterday and will now play next week for the final, the District 11 championship. We have football tonight away at Northampton. And our quote for today is, trust is earned, respect is given, and loyalty is demonstrated. Betrayal of any one of those is to lose all 3. Rovers, have a great day.
Okay. During the announcements, we figured out the value of A prior to the announcements. We figured out the value of C. Which letter don't we have? B. Okay. We still need to find the letter B. This is the way that you do that. You go back to your line of work that was in red. On the right-hand side, prerequisite skill is back again. We need to simplify the right. So notice I foiled out the quantity. I distributed the x, wrote that here. But now I need to go through and multiply. So I have ax squared minus 6ax plus 9a plus bx squared minus 3bx plus cx. Okay? That's probably the worst part of this procedure, having to do that. But now, here is where this is amazing. Okay? If I give you an equation, I'm going to do this in green real quickly, and I say triangle plus circle equals triangle plus circle. Do you agree that the triangles have to be the same? Triangles are triangles, correct? Okay. Think of shapes. Instead of a shape, think of ax squared. All of the quadratic terms have to add up together. All of the linear terms have to balance in an equation, and all of the constants do. So if I'm looking for the letter B, I either have to choose quadratic terms or linear terms because B only exists in those. I am going to choose quadratic. So I'm going to take bx squared. I'm going to take ax squared. There is no cx squared. And I'm going to take this green here. Notice what I have. 1x squared, great marker, is equal to, we said a was negative 4x squared plus bx squared. Can you tell me what b is to make that true? 1 is equal to negative 4 plus b. What's b? B is 5. And I'm done. Okay. You might want to go back and just rewatch this one example. You have the next assignment on your list. The first 3 problems are very short. I think it's only 2 letters you find. Real quick. Yes, ma'am.
Why did you choose
The triangle ones? Because if I went to the linear, then I would have had to put in C also. I would have to use the CX, the BX, the AX, and the 10. So I picked the shortest one. You get the same answer. You just have to then plug in a C value, which we solved for.